In this video, we will going to know about the nature of carbon halogen bond. Before going to know the nature of carbon halogen bond, we should first know about the basics. As you all know that hydrogen atom has one electron in its outermost shell, and in order to complete its duplet to gain a noble gas configuration, it needs to gain one more electron. As the same carbon atom, when it comes to carbon atom, the carbon atom has 4 electrons in its outermost shell, and in order to complete its octet, it needs to gain 4 more electrons. And when it comes to fluorine or any other halogen atoms such as fluorine, chlorine, bromine or iodine, they have 7 electrons in its outermost shell, and in order to get a noble gas configuration and in order to get complete the octet, it's need to gain one more electron. So this makes all the halogens electronegative, and fluorine is one of the most electronegative atom. So coming to the nature of carbon halogen bond, the carbon halogen bond of alkyl halide is polarized due to electronegative halogen. The halogen connected to the carbon in haloalkanes or alkyl halides is electronegative, and due to its electronegativity, it pulls the electron density from the carbon towards itself. So this make this bond polarized. So as the electron density is moved towards the halogen gains partial negative charge, and whereas the carbon which loses the electron density, it gains partial positive charge. This makes this carbon halogen bond to be polarized. This can be seen in this electronic configuration. As you can see that hydrogen when connected to the carbon with covalent bond, it shares its duplet. Hydrogen complete its duplet, whereas carbon it's able to complete its octet. But when this carbon shares electron with a fluorine atom, so as fluorine is electronegative, so what it does, it pulls the electron density from carbon to itself, and this makes the carbon fluorine bond to be more polarized. Now, as you know, the carbon halogen bond is polarized, so we will going to know about that fluorine is the smallest in the size, whereas iodine is largest in the size. So when it comes to CF bond, the fluorine is smallest, whereas in CCl the chlorine will be larger as compared to the fluorine. So when we move down the group, we will see the bond length will increase because fluorine is smaller compared to chlorine. So chlorine is bigger in size and bromine is bigger in size than chlorine, and iodine is the biggest. So that's why down the group this carbon halogen bond will going to increase. So here is one table which will going to show the bond length. As you can see, the bond length down the group will going to increase, moving from the fluorine towards the iodine. Fluorine is having 139 picometer bond length, whereas the iodine is having 214 picometer. But when it comes to the bond enthalpies, the bond enthalpy follow the reverse order, because bond enthalpy is the energy required to break the bond. So CF bond will be more stronger. So it will require the CF bond will be more stronger. So it will require more energy to break, whereas CI bond will going to break easily. So that's why the bond length will going to increase and the bond enthalpy will going to decrease. But when it comes to the dipole moment follow some other path, because dipole moment is dependent on two factors. First is bond polarity and second is bond length. Now, when it comes to from moving towards fluorine to chlorine, the bond length effect dominates. That's why the dipole moment increases. But when it comes to from chlorine to iodine, there is a drop in polarity that dominates, and that's why the dipole moment decreases. So that's all about the nature of carbon halogen bond.